Generalizing splatting algorithms for 3D reconstruction and immersive web visualization platform. Before we dive deep, what is a 3D reconstruction? Basically, it's like the reverse process of photography, where in photography, we capture a 3D scene and it reduces to 2D. Whereas in 3D reconstruction, we used those multiple 2D images to reconstruct the lost depth and geometry of the real world to bring it back to 3D. For example, this is a collection of 2D images of the Colombo National Museum captured in various angles. These are aligned to generate a 3D point cloud, capturing the scene's geometric structure. We then model each point with 3D Gaussians to generate a photorealistic 3D reconstruction of the museum. This technique is known as 3D Gaussian Splatting. Now, what are 3D Gaussians? We are all familiar with 1D Gaussians. Then, when lifted to 2D, it looks like an elliptic disc. In 3D, it looks like an ellipsoid. Various combinations of the center and covariance matrix produce different shapes of 3D Gaussians. With millions of such 3D Gaussians, or rather ellipsoids, the museum is built and then projected to 2D Gaussians, which we refer to as splats upon rendering. This process is known as splatting. When navigating through the scene, you can see the user's camera viewpoint changing, which is in red. The green camera viewpoints represent the input images. There have been various advancements in 3D Gaussian splatting. However, they all remained constrained to the Gaussian primitive. We expanded beyond that to generalize the primitive to a broader class of functions which we refer to as DARBs, or Decaying Anisotropic Radial basis functions, which includes the Gaussian family. The integral of a Gaussian is also a Gaussian. This interesting property cannot be seen in many other functions. Therefore, we introduced a correction factor to approximate the 3D to 2D projection of DARB functions. Each DARB function performs differently. For an instance, half cosines demonstrate faster convergence, while inverse multiquadric functions demonstrate reduced memory footprint. Although the loss curves are similar across DARBs, the training speed is faster in half cosines. The race cosine reconstructed scenes are comparable with that of Gaussians. Moving on to real-world implementations of 3D Gaussian splatting, the next phase of our project was to build a unified immersive web visualization platform which supports both a web viewer and a VR viewer. This is a glimpse of the various scenes we visited, collected, and reconstructed. A sample navigation via our web browser can be seen here. Usual game commands such as WASD can be used for navigation. Moving on to our VR viewer, this is a sample immersive experience through the Independence Memorial Hall, which was reconstructed using 3D Gaussian splatting. It enables a real-world scene to be experienced in virtual reality with 6 degrees of freedom. We believe unified web and VR viewing platforms of real-world scenes have the potential to transform various industries.